Hi, welcome to our presentation, Solving the Mathematical Practices Puzzle, How to Develop Student Skills and Metacognition in Math. We're really excited to have you here.
Good morning, I'm Marilyn Salceda, and I'm an instructional coach for Elevated Achievement Group.
And I'm Leslie Fields, also an instructional coach for Elevated Achievement Group. So today we have a session designed for you around this agenda with this outcome. We want to make sure that we answer these questions for you. What are the standards for mathematical practice and how do they differ from and work with the standards for mathematical content? Why is integrating these standards so critical for young students' mathematical development? And what is this going to look like in the classroom? So basically, Marilyn and I are going to do some talking and discussing around these first two questions. And then, because we're teachers and we're hands-on, we want to make sure that we give you as full a picture of what this looks like with children. Now, a little caveat to this, we are in the middle of a pandemic, so this will not be an actual classroom demonstration. We had to rely on our friends and family to be able to work with children. So it's, at that point in the presentation, you will see videos of Marilyn and I working with some kiddos to really demonstrate what this can look like for you and your students.
Right.
Marilyn, you have.
Yeah, and as with any teacher, want to make sure that you understand what the learning outcome is for this presentation. So our hope is that by the end of the presentation, you'll actually have a better understanding of some of the tools that you're going to need to implement the strategies that that integrate both the practices and the content, and specifically with pre-K through the second grade.
And it's really, one thing we want to really highlight is tools. We as educators at Elevated Achievement Group, we are dedicated to making sure you have as many tools as possible. So you may see Marilyn and I working with a book that we have produced that has a lot of these tools and these strategies in it. So Marilyn's showing the book cover right there. It's just something that we produce for teachers. The other thing that you want to make sure you have is you want to make sure you've downloaded this PowerPoint as well as the additional chunk of tools that we've provided for you as part of this presentation. So if you haven't already, hit pause on your I guess you're calling these sessions, hit pause on your session and make sure you download from the NCTM website these handouts and tools that we've provided for you. So, without further ado, are we ready to get started, Marilyn?
We are. Let's get going.
All right, let's go. What are the standards?
Okay, so what we want to do is actually, why are we spending time on this today? Why are we talking about mathematical practices and the content standards? Well, it kind of goes back to the math wars that have been in existence since this country's been has begun. Bottom line is there's been this conversation about what's more important, skills or conceptual understanding. And that's really been what the math wars have been about. It's really been pitting those two pieces. Is it rules and memorization, or is it really the critical thinking that goes behind and making sense of what those procedures and processes are? So really the question's been, should teachers offer students rules and facts to memorize, or should they give students an opportunity and materials to actually reason through why those rules and those facts are important to memorize in the first place? And you want to talk a little bit about this quote?
No, it just makes me think about my own experience as a child learning math at the time when math facts were very, very much the emphasis. And so while I could memorize all of my multiplication tables, I actually couldn't tell you. I remember crying in first grade when the teacher showed me my first number sentence that had that X, that multiplication sign. It was like the last day of first grade. And I remember going home because I was little miss, wanted to do it perfect the first time, every time, and crying to my mother because I just didn't understand what she was trying to tell me, because it was approached from the perspective of, here's something you're going to have to memorize. I was great at memorization. I knew all of my math facts by third grade, but the idea of what multiplication was in terms of grouping and then multiplying those groups by a number of groups just never really sat with me. And so I was really appreciative when, as a teacher, the new standards came out and really started to say, you know what, we need a balance. It is important. There's certain things you just have to memorize, but there really is some deep understanding that needs to go along with those facts. It's kind of like, you know, the difference in reading between phonics and actual comprehension skills. You know, you want the kids to be able to decode things, but you also want them to understand what they're decoding and the meaning behind it.
Let's compare the two standards right now. You've got the standards for mathematical content, which most teachers really have a strong understanding about. It's really a list of things that kids need to be able to understand and do. Here are 4 things that are really specific to the content standards. Number 1, it's really has a focus on skills. It's a step-by-step, it's progressive from grade 1, kindergarten, all the way through 12. There are certain skills that are learned along the way. That's the first thing. The content standards are also organized by grades. So if you look at the requirements for first grade, they change by the time you get to second grade and then third grade, and then it continues, it progresses. Most teachers have a pretty strong understanding of what the content standards are because it's what we've really been focusing on, especially the last 15 to 20 years, the content standards. And what makes the content standards so easily accessible for teachers and makes it easier to teach is because it's so much easier to test. It's pretty finite. The skills are very specific.
Right.
You know, now with the mathematical practices, it's a little bit different because now you're talking about moving from actual the student's ability to be able to do skills to now their ability to be able to think through the process, that conceptual understanding of what the skill is asking you to do. And can they articulate, can they really say in their own words what they're being asked to do and why? So it's really much more general. It evolves over time. Okay. The standards are the same. The mathematical practices, those standards stay the same, whether you're pre-K all the way to high school. Okay. Now, it might change on the questions you need to ask, and we'll talk about that a little bit different, and the responses you might get from the students, but the standards don't change. There are 8 of them, and we'll talk a little bit more about that. They're less familiar to teachers. And while they have been presented to teachers, there really hasn't been a lot of information that's been given to explain what exactly does this practice mean. And then because it's about a process of thinking, it's a lot more difficult to test.
So how did we get here, Marilyn? How did we get to those mathematical practices?
Well, and I'm really excited that we're talking to the National Council for Teachers with Math because they played an integral role in determining what those standards are. The National Governors Association in 2010, because they understood the gap that it was starting to exist and we were starting to see in our students with their struggle to be able to really explain and articulate that conceptual understanding of the skills they were learning. They went to 2 organizations, the NCTM, which is the National Council of Teachers, who already had what they called process standards. If you'll look on this PowerPoint, it's problem solving, reasoning, improved communication, connections, representation. So already there was an explanation that said, these are really the practices we would like our students to be able to do as they're working with their skills. The second organization was the National Research Council, and they called theirs the strands for proficiency. If you look, it's conceptual understanding, procedural fluency, Okay, their ability to actually articulate and see it from context to context, strategic competence, adaptive reasoning, and the representation. So then the National Governors Association took those two and said, hey, these two organizations of mathematics have already done a lot of the thought process.
Mm-hmm.
How can we take those and combine them and come up with what we can now refer to as the standards for mathematical practices, so that we have two things now that we can work with our kids on, not just the skill, the content standard, but now what's the reasoning, what's the metacognitive thinking skill. Okay, and these were the 8 that they came up with, and I won't read them all to you, but they're right there. And so that became the secondary piece that math teachers now realize, oh my gosh, in order for my students to truly learn the skills and the content to the level that they need to, and so that they can have fluency and a deeper understanding, these are the standards that they're going, and the mathematical standards practices that they're going to need to really focus on it, as well as the skills. Make sense?
It makes sense. I love history. I love getting the historical perspective, but it is history to come to life. But my next question is, Marilyn, why is this going to be important for young children? We're talking about pre-K, K, 1 and 2 specifically. These are 8 standards for K-12. There's some really heavy content in here, and these are babies. So why is this critical to do that?
Well, let's look at it this way. Here's my analogy. I'm a golfer. Okay. One of the things that I've learned is I only get better from the beginning all the way through the end, whether I'm a novice or I'm an experienced golfer or any athlete or anything, whether you're learning to play the piano, you're learning an instrument, you're learning to sew, you're learning to build something. Okay. The more you do that, the more you create muscle memory. It's no different. We cannot expect our high school students or our middle school students to be able to use that metacognitive skill if we don't begin to develop it from the very beginning. Now, that's huge, because there are ways to work with a pre-K or a K or a first or a second grader, and it's all in the questions that you ask them, the responses you try to elicit from them. Okay, so that by the time, because remember, the mathematical practices don't change from early age through high school.
Right.
So keeping that in mind, how do we change that?
Yeah, I love that. I didn't think about it that way, but it really is, like, especially if you have a kid from pre-K in your school system, from pre-K or even K all the way to 12th grade, it takes some of the pressure off that you don't expect the kids to have these 8 practices mastered by the end of your time with the child, but you do have to lay that foundation so they start to recognize they have that muscle and start to exercise that muscle for the next 13 years, so that they are really fluent in this metacognitive thinking and this language. I love the quote that we have up here. It's from the standards from the National Governors Association. I love and hate this quote, actually, because the first part really was a light bulb for me, especially as a teacher of young children. Because again, my question was, what does this mean for young children? This is pretty heady stuff. But this statement about it being a hallmark of a mathematical understanding is the ability to justify in a way that's appropriate to the student's mathematical maturity. I do love that, because I'll get to that in a second. Why a statement is true or where the rule comes from. That means that there's a world of difference between a student who can just summon something out of memory or explain what they're talking about and why it's known to be true. The part I don't love about this as an early childhood teacher, that's an algebraic equation there. That's I'm just trying to get children to count. But it really makes me think about, okay, what does this mean for my kindergartners, for my first graders? Well, what it means is, when we're counting, it's more than just that rote counting. That's important, but it's understanding that rote counting has a sequence, and that sequence has a pattern, and those numbers in that sequence have quantities, and those quantities can be demonstrated and proven with objects, with fingers, with drawings, whatever a kid needs to prove. And those numerals are written symbols that do have a deeper understanding behind them. So it's less than just, can you count to 20, and more of, okay, show me 20, and then being able to do all of that. And you start that young. And those are things that we've been doing as kindergarten teachers, but I don't know if I was doing it as intentionally as I should be doing to then attach it to these mathematical practices, especially.
And so that's, that's really important. What we're talking about is how do we develop a child's ability to reason, a child's ability to make sense of things, just to explain what they're thinking, to explain where they don't understand, to explain possible challenges, pitfalls. So that's amazing. So you don't just do that at the middle school and the high school when the content becomes more difficult. The more difficult the content, the more advanced the questions and the vocabulary can be. But as a child is in K or pre-K through second grade, you can still ask questions at their level and expect responses at their level that start to build the, oh, I have to think through this process. So yeah, so muscle memory is extremely important. And pre-K through second grade teachers actually hold an extremely critical role.
Okay, so how do we do it?
Well, exactly. Well, one of the things that I really appreciated about the thinking about the mathematical practices and the content is there really has never been any document, any resource where you can go to everything and try to find it where it makes sense. And that's what we've really created. So if you look on this page, it talks about the standard for mathematical practice. That's the first one, which is making sense of problems and persevering to solve them. Okay, so let's talk about in the real world as our teachers are trying to implement, what does it mean? It means that a child can say, I can determine what the problem's asking me to do and not give up till I solved it. Okay, but how do we get there? Okay, how do we get there? Well, there are two things that needs to happen. If you'll go ahead and flip to the next slide, we'll talk about, well, let's talk about progression. Since we're really looking at this, we talked about how it needs to be muscle memory. If you look at this for the making sense of problems and persevering in solving them, notice this is the learning progression. Remember we said it becomes more complex. If you really analyze the kindergarten through third grade, you'll notice that there are a lot of similarities, and then you have to pick out, yep, right there. If you'll notice, there are a lot of words that are very similar. But when you start to go through and dissect them and really look clearly at what it says, you'll notice that there are some key differences. Okay, so let's look at the first one. In kindergarten, students begin to build understanding that doing mathematics involves solving problems and discussing how they'll solve them. Okay, and it gives you a description of what the students will do. They'll explain to themselves, they'll look for ways to solve. It tells you all that. Then at the bottom, it may say, or they may try another strategy, because when you go to first grade, okay, go ahead, there you go. If you'll notice, now it's changed. Okay, your kindergartner begins to build the understanding and may try another strategy. But as you dissect the first grader, now it's gotten a little more complex. Not only are they beginning to build it, they now realize, they see it, that doing math involves problems and discussing how they'll solve them. Also, it's not they may try, they are willing to. Now all of a sudden, because I'm used to trying another one, I'm more willing to risk take. Now I'm willing to try another approach to see if it works. Will it work? I don't know. And it doesn't really matter because the student can now start to tell you. You can ask questions, and we'll talk about those. Well, wait a minute. Why did you try that approach? And they need to now start developing that that ability to kind of critique their own reasoning. Okay. And then you get to second grade. In the second grade, they still realize, but look where it changes. If you read that, all of the lines are exactly the same until you get to the end. They make connections now about the solution and plan out a problem-solving approach.
Mm-hmm.
Okay. So what is so cool is, to me anyway, as a teacher, is as I'm looking at the learning progressions, I don't have to reteach everything that's in there. I will support it. I'll make sure that I continue to give practice because, you know, everyone learns at a slightly different time. But now I can say, oh my gosh, my job is really to make sure that they're willing to try other processes. Or as a second grade teacher, oh, now I want to make sure they can make conjectures about the solution and come up with a plan. So how, and that's by asking all of the right questions. Okay. So, and that continues all the way through high school. But since our focus right now is pre-K and all the way through second grade, any thoughts coming to you?
Oh, I just was thinking, yes. And I love how it progresses. It really gives us an opportunity to understand not just what's new, but also what's the same for them.
Mm-hmm.
And I would say for pre-K, we just need to think about what is it they're being expected to do in kindergarten, and just really getting pre-K kids to begin that same understanding that it involves problem solving and getting them to answer that question, does this make sense? I'm not sure I would worry about a pre-K kid trying a new strategy. It would depend on the kid. And that's really also, you know, one of the things that we always say is the teacher's the one that makes those decisions.
Exactly.
This is a tool. This gives some great guidance, but then as teachers, we make those decisions of where the child is in the progression and what the child needs to continue progressing. So,
and then again, you know, we're talking about these, and I'd be saying to you, great, Leslie, I hear you. How do I do that?
right.
What are some of the strategies? Well, what I always tell teachers is, you know, as you're presenting material, you know, you're going to be doing the I do, even with our young kids. But there'll be times when you need to elicit information from them. Remind yourself that you need to ask more questions than you make statements. Okay. So there very much are questions to actually foster that kind of thinking. Here are some of the questions you can ask a first grader, for example. Hey, what's the problem? We're going to do blah, blah, blah. And you just, you know, you first explain to the students, this is after you've done your first initial instruction. You go through and say, okay, now that you've done this and that we've talked about the skill that you're going to be learning, what do I want you to learn when you leave class today? Now you can start to focus and say, okay, this is a problem that I want you to try. Okay. And let's read it together, or let's do together, whatever. And then you say to the student, okay, one of the questions you say, so the very first thing you need to figure out is, so what's the problem asking you to do? Mm-hmm. Oftentimes that's where you'll see either a blank look, and you need to say, well, what do you think it's asking you to do? And you ask that question. And if they can't say, well, what do you know, once they tell you, you can say, oh, well, how can you get started? What are some of the things that you need to do? How do you want to solve the problem? What are some ways you can solve this problem? Mm-hmm. What can you do if you get stuck? It's really about questioning them step by step. If they make a mistake, you can say, oh, I see that you did thus and such. Can you explain to me why you did that? Mm-hmm. Okay. And then if the student says, well, I'm not really sure. Well, what were you thinking of that made you do that? Show me. Okay. Will that work? How do you know, so those are the kinds of questions that you ask students. The next piece is, okay.
Well, I have a question. Mm-hmm. So, as a very literal person, mm-hmm. when I see this tool, mm-hmm. Do I ask every single question in this exact order with every kid?
Absolutely not. all this is, well, I'll be honest with you. I believe in my own head that the number one question to ask a student before they even start is, what's the problem asking you to do? Across the board.
Yeah.
But based on what the student's response is, those are the questions you ask. If a student can explain that right from the get-go, you can say, okay, how are you going to know if you did it right? And that's all the way down the bottom. How do you know you've solved the problem? Okay, I'm going to leave you alone for a few minutes. How are you going to know? And if they can't answer, you may ask a questions not even on this list. All this really is a tool for teachers to use. And when you're first starting off, it's like, oh my God, what kinds of questions do I need to ask? These particular questions really focus on students making sense of problems and persevering in solving them. Other practices, okay, you'll notice they pretty much start with, what's the problem asking you to do?
Right.
But the others may be different depending. So if I'm asking you, for example, to reason abstractly, the question I ask may be such that I'm asking you a question that makes you abstractly think. But no, these are just examples. These are questions that if you need to look at, well, ooh, what are some questions I could ask? They're right there.
So I love this. I, as a teacher, tend to talk too much. So I really love this, like, okay, I need to frame it differently for myself in starting with the questions. But what do I do, Marilyn? Like, there's a lot of kids that first, they need to develop language. Even if they are thinking, what is this asking me to do? They may not have the language to tell me yet. So where does that fit in? Is it okay for me as a teacher to begin with, all right, I'm going to be teaching this content skill, and I really want to emphasize the math practice of making sense and persevering problem solving. So as I do my initial instruction, I'm going to be infusing these questions more as a rhetorical, that I will model the answers as a teacher, because for young children, especially young children that come from language deficient homes or homes where a second language is spoken, they may not, again, this is heady stuff, they may not have the language at first. And so is that okay? I mean, I'm happy to give space for children for the wait time, but I also don't want children not to have, they need language models is what I'm saying. So is there a place for that in this?
Absolutely. The example that we have is first grade, but you have to realize, and go ahead and hit the next button for me.
Yeah.
Okay, if you'll notice, along with the questions to foster metacognition, all they are examples for teachers who want to get started, and they'll look at them and go, oh yeah, I know that. Here are some ownership statements that students can ask, but you mentioned it yourself. A pre-KK student can't read, and they certainly can't write. Okay, but these are statements that you can model as you ask the questions. If a student, and most students will give you a fragment, they won't give you a complete sentence, you can say, and if you say, for example, so what's the problem asking you to do? They'll say, put them in order. And you can say, you're right. The problem is asking you to put them in order. Can you say that for me? The problem is asking me to put them in order. What you're doing is you're creating a verbal sentence frame.
And it really, I like that term ownership, because it tells me that when a kid is able to verbalize that, they're owning that content, they're owning that learning for themselves. But again, it's just going to be process, right? Just like building math muscle memory is a process, so is language development. And one of the critical pillars of that development is the modeling of not just the words, but the thinking for children to be able to then pattern themselves on.
These are the statements that you want students to be able to start getting used to saying, because what it does is it helps them articulate what's going on up here. Sometimes what that means is that teachers need to say, when I get stuck, I blah, blah, blah. What do you do when you get stuck?
Mhm.
Yeah.
Love it.
Yeah.
Love it. Okay, I'm ready to get started. I want to see it in action with the kids.
Okay.
So what you're going to see next in our presentation are some videos of Marilyn and I, and we look forward to you being able to see what this looks like in action when you're working with kids to help them better develop that mathematical practice standard of making sense and making sense of problems and persevering in solving them. And once those videos are over, we'll come back for a wrap up. So enjoy.
What color is that?
Blue.
Okay, so here's what we're going to do today. I want to talk about patterns. Okay, a pattern is something like if I put these in a particular order, like I put red here and green here and blue here and orange here and black here, I would want you to make the same pattern. Okay, so hold on. So hold just a second.
Well, this is how mine is.
Okay, but you see how mine is?
Mm-hmm.
Okay, what I want you to do is I want you to make the same pattern. So what do you think I want you to do? What did I just say I wanted you to do? Tell me.
I forgot.
Okay, I need you to make the same pattern.
But I can't because I don't know how you do it.
Okay, so what?
And mine's not in the same order.
Okay, so it's really great that you said, oh, I don't know what to do. So let's look at it this way. What color is that?
Red.
Okay, so which one do you need to put
What
first?
color is
Listen, what color do you need to put over here so that it's just like mine? What do you need to put? Awesome. What color is this?
Green.
So what would you have to put next to the red?
Green.
Awesome. So can you follow the pattern? What comes next?
Blue.
Uh-huh. And then?
Orange.
And then? So what do you see about these? It's the same. It is the same. Absolutely. So what did you do when you got stuck and you couldn't figure it out? What did you say?
I did it.
You did do it, but what did you ask Grandma?
I asked. I didn't know how to do it.
Yes. And what did I do? Did I help you?
Yes.
Okay. So I'm going to shuffle these up. Okay.
I'm gonna shuffle mine up.
Okay. Shuffle yours up. Okay. Are you ready? I'm going to put a different pattern from the last time. And this time I want you to make the same pattern that I made.
I'm just going to make a stand-up pattern.
It doesn't matter as long as you have them in the right order, because that's what a pattern is. So which one comes first? Why don't you lay them down? It might be easier. And then you can stand them up later. Okay. So which one did you put first? Which is what? This one. Yes. And which one needs to come next? Oh, which is what?
Blue.
Is that blue?
I don't remember.
What color is this right here?
Oh.
What color is that? What color is this?
Red.
Perfect. So what color needs to come next?
Green.
Is that one green?
No.
What color is it?
Blue.
So which one needs to be? Oh, so what did you do? You fixed it, huh? Okay, so what color comes after the blue?
No.
Why did you change it? Good
I
job.
was wrong.
Because you were wrong and you fixed it. Okay?
This is the same pattern.
It is the same pattern. Give me
Now I'm
five.
gonna
Give me
shuffle
five. Give me five. High five. Awesome.
Are you ready to do some math?
Yep.
Okay. What is this problem?
What is 12 minus 5?
Excellent. Good reading. What is 12 minus 5? So what is this problem asking you to do?
Figure out the correct number and prove it.
Okay. Oh my gosh, that's so smart. You were so smart. What does that mean though? What are you figuring out?
What 12 minus 5 is?
Okay. That makes sense. So how do you want to get started figuring that out?
Counting in my mind.
Okay. Do it and then tell me what you're doing.
Okay. What I'm doing right now.
Mm-hmm.
I have 10 and 2.
Oh,
12.
okay.
Seven.
High five. Now, can you prove it using maybe like a drawing or our wonderful lizards? I think you're right, but I want to make sure we can prove it and it makes sense.
Okay.
How do you want to prove it?
With the lizards.
Okay, do it. Show me.
Okay, so I'm gonna need to get all 12 of them.
Okay.
I'm just gonna use that for yellow,
Okay.
green, blue, and purple, and pink, and I'm gonna need another purple. Okay, so there's 12.
How do you know?
Or wait, no, that's not. So there's 4 over here and 4 over here, 8, 9, 10, 11, 12. Now there's 12.
I love it.
I just counted on. 8.
I like how you told me what you were doing, counting on. That's a good strategy.
Okay, so now I have 12.
Okay. Now what are you gonna do?
I'm gonna set them out. Just like that. Okay. Coils.
Okay. Then what do you do?
What I was thinking in my mind, I was taking away 5 of them,
Mm-hmm.
and if I take away 5 from the 10,
Mm-hmm.
I have 2 and 5 left.
Mm-hmm.
So I add the 2 to the 5, and then it's 7.
So how does making sense of every math problem you come across and persevering in solving it, how is that going to help you?
Well, honestly, my brain just tells me what to do.
Well, that's really smart to listen to your brain. I really appreciate that you shared what your brain was telling you, because that helped me understand that you knew what you were doing.
Welcome back. We hope that you enjoyed the videos and that they were helpful to you. Let me talk a little bit about what I reflected on after I had an opportunity to work with Raymond. One of the things that I noticed was that it was really important that I give him something very visual. Then, as I was going through and actually creating what I thought were patterns, when he said to me, "Oh, Grandma, I'm putting it in order," I realized, oh my goodness, I was actually creating a sequence for him. Then, as I was thinking, oh my gosh, Marilyn, you didn't do the pattern, it occurred to me that, wait a minute, at a pre-K level, it's important that kids are able to identify a sequence before they even get to a pattern. So as I'm looking forward to the next lesson with him, I'm going to need to really fine tune the idea of the difference between putting something in order and actually finding a pattern. So those are kind of the things that I was thinking about.
It makes total sense, Marilyn. I mean, that's the thing, is one of the foundational skills for pre-K is copying patterns. And so for you to be able to work with him and lay that foundation of copying that pattern, patterns do have an order, and it's units, pattern units that go in an order. So you're already well on your way. But more importantly, what I saw was you were starting to build that language we talked about, with him being able to use those words order and sequence, and being, more importantly, understanding that he could start to express to you what he was thinking. And you nailed, I mean, he just totally, completely understands persevering. that was part of the mathematical practice. I mean, content skills are important, but you were developing that mathematical practice of persevering. He said, I don't know how to do it. And you reiterated that. It was a great thing to see. I know that I just really appreciated watching the language being developed, because that is what we need to start doing for pre-K and K, especially getting them talking about math with math language.
Right.
Because as I noticed watching our two videos, that the difference in the language between a pre-K and a first grade student is a big deal. And so working with my first grade student to be able to use those mathematical words about with like 12 minus 5, minus, that's mathematical vocabulary that can be built as early as kindergarten or even pre-K. But more importantly, since she had that vocabulary, and she had the mathematical concept and content skill of subtraction, using the strategies of adding on and grouping, she was ready to start to express her metacognition, but she wasn't quite there yet. At the very end, if you notice, you go back and look, asking her what it means to make sense of that problem and persevere in solving it, which she already did, she's not quite ready to articulate with. So I know I need to continue modeling what that means for her, so that she can start to express it back to me, because she's there, she just doesn't quite have the language for it.
Right. And the whole purpose of the videos really is not so much to focus in on what the kids are doing, but what does it look like on our part as teachers? How do we actually work with them in such a way that we're eliciting this information, this language, these skills? So it's really about what we do. What are the questions that we're asking them that elicits information? Because when you look, we're working one-on-one, and most teachers don't get the opportunity to do that. So don't worry so much, is what I would think to our teachers. Don't worry so much about the fact it's only one kid. Wow, if I only could teach one child.
Right.
It's as you're working with your entire class, with your kiddos, right? Are you thinking about the questions that will elicit those responses from them?
Exactly. Well, that's a great segue into our final wrap up. We want to thank you for being here today. It's certainly been a pleasure for us. We hope that you have been able to really not just gain some tools that can help you, but also see some examples of what it means to be developing students' skills and metacognition in math.
So as good teachers, we always try to revisit our lesson outcomes. Let's take a look. If you'll recall, one of the things that we said was that our expectation would be that you would walk away with having gained a greater understanding of the tools that you need in order to actually implement both the content standards and the mathematical practices, especially at the pre-K and the second grade levels.
So again, it's just been a pleasure. We want to make sure you walk away with those tools. So if you haven't already, use this QR code or go to our website and you can download not only this presentation, but your own set of tools for the mathematical practice standard 1 for pre-K through second grade. That means you'll get the mathematical practice, the I can statement for the students, the expectation for that standard once the children reach high school level. And then you will also get those learning progressions that we looked at, so that you can really dig deep into what they need to be learning at each grade level, as well as what they can repeat. And then finally, you'll have examples of what that looks like at the pre-K, K 1 and 2, along with those questions to foster metacognition and those oh so important ownership statement prompts. So Marilyn and I are going to be hanging out in the NCTM's Zoom rooms for an author Q&A. We would love to meet you, talk to you a little more about what we've been doing and what we can be doing with kids. And so we hope you join us. We will be there at 10 a.m. Pacific time, 11 a.m. Mountain time, 12 straight up high noon for the central time zone, and 1 p.m. on the East Coast. So thank you again for sharing your time with us. We hope it was a valuable experience for you. Bye.